Well, we have another question here, question 7. Question 7.1 says, determine the first derivative of f of x from first principles if f of x equal to 2x squared minus 1. Now, I'm going to write the question over here. It's question 7.1. Okay, 7.1. So we are looking for f prime of x, okay? But now we need to find it from the first principle. The first principle says that the first derivative, okay, or f prime of x is equal to the limit, okay, of the difference between f of x plus h minus f of x all over h, okay? And then h approaches 0. Now, we do have f of x already given, as we can see, f of x is there. Now, I prefer to work out to do it separately. I think this way is much helpful. Okay, I'm gonna do first f of x plus h, okay? I'll do this one, f of x plus h, this part, work this out. This will be, I'm gonna write here, f of x plus h, simply means wherever we see x, we're going to substitute by x plus h, okay? F of x was given by 2x squared, so 2x squared plus minus 1, okay? So we will substitute, instead of me writing x squared, I'm going to write x plus h, okay? And then we will simplify this part, okay? Extend it, okay? So this will be like, note that this is not equivalent. X plus h to the power of 2 within the bracket is not the same as x squared plus h squared. So over here, we're going to write 2, okay? Open bracket, x plus h, close bracket, open another bracket, x plus h, and then minus 1. Now we're going to times this. So we're going to do x times ax, x times h times x, and h times h, okay? And then this will be equal to 2, open bracket, x times x makes x squared, and then x times h makes xh, and then h times x makes xh, hx is something as xh, and then h times h makes h squared minus 1. Now this will be equal to 2. We can simplify, combine like terms within the bracket. That makes x squared plus 2xh, because you know these two are just like terms. We can combine them. It makes 2xh plus h squared minus 1. If I times by 2, the whole equation would be like 2x squared plus 4xh, okay, plus 2h squared minus 1. Now this is basically f of x plus h. Now remember that f of x itself was given by 2x squared minus 1. I prefer to write it this way. Now what I'm going to do, I'm going to minus, I need to work out the numerator of this fraction, okay, of this fraction there, this fraction, the numerator. So if I to do that, I can just minus f of x plus h and f of x, or minus f of x from f of x plus h. Now, you know, 2x squared and 2x squared will fold, and then negative 1 minus 1 will make negative 1 plus 1, and this 4 also, and then the difference will be equal to 4xh plus 2h squared. Now, therefore, we have f of x plus h minus f of x equal to 4xh plus 2h squared, okay? Now, if I need to work out now the whole fraction here, I will divide both sides of the equation by h. I'll divide here by h. I will divide there also by h, okay? So by doing so, to divide them by h like that, like if I look at the numerator, this part here, all this part here, we can take h as a common factor because we do have h here and then h squared there. So we can take h as a common factor. So I can take h as a common factor, and this will be equal to 4x plus 2h, okay, all over h. Now you can simplify the h like that, and then let's just move my board like that. We'll have like f of x plus h minus f of x all over h, okay, equal to 4x plus 2h. Then the next thing to do is to introduce the limits. Okay, I'm going to introduce the limit both sides of the equation. H approaching 0, and a limit there also with h approaching 0. Okay. Here we look at f of x plus h minus f of x over h equal to limit of 4x plus 2h. Okay. Now to solve this, this is just where we're going to substitute h by 0. Okay, we'll sub h by 0 there, and then this will be like 4x plus 2 times 0, and then this is just equal to 4x. So this is f prime of x, because the part that we see here is this is f prime of x according to the formula. That's the formula of the first of a derivative, okay, from the first principle. So we've got like f of x, f prime of x equals to 4x. Now we got the answer. Okay. Well, now the following question is question 7.2.1. 7.2.1. Okay, it says determine dy dx. Okay, d of okay, let's see it again. I think I'm close here. Yes. Question 7.2. Now we're doing 7.2.1. So now it's like the derivative of the function is here, of this function with respect to x. Okay, the derivative of this function with respect to x. This is how we can read it. Now here we can see it is like the fifth root of x to the power of 2 plus x to the power of 3. Now let's do it there. So it's the derivative of the fifth root, okay? The fifth root of x squared plus x to the power of 3, okay, with respect to x. Now, to solve this type of differentiation, we need to do a few things, okay? We're going to, I know it's going to be difficult for us, especially from the grade 12 knowledge of rule of derivative. It's going to be quite difficult to differentiate the function the way it is. It may be difficult. Now, what we do, the best way I suggest is to transform the function, to write the function in an easier way to differentiate it, okay? You see, the function that we have here, we can transform it following the law of exponent. For instance, you know, radicals and exponent. The law says that square roots of, not square root, but the nth root of a to the power of m is equivalent to a to the power of m over n. Okay, so we can change the function, what is inside the brackets here. So d of dx will become, the function here will become x to the power of 2 over 5, okay, plus x to the power of 3. Now, we can start differentiating the function. We can use this formula. This is the formula we can be using. The formula will be, sorry about that, a x to the power of n derivative. This is equivalent to n times a times x to the power of n minus 1, okay? So over here, to differentiate that, when I start using this formula, remember that here a is just 1, okay? Over here a is 1, that a, and then the exponent is 2 over 5. Similarly, here also a is 1. When you don't see the coefficient in front of the x, understand it is 1, and the exponent is 3. Now let's now solve this. When we solve this, we don't need to write d over dx anymore. We can just write 2 over 5, okay, n times 1 times x to the power of 2 over 5 minus 1 plus 3n times a, which is 1, times x to the power of 3 minus 1. Now this will be equal to 2 over 5 x to the power of 2 over 5 minus 1 is negative 3 over 5, okay? Negative 3 over 5. You can check that in the calculator. You can check the calculator if you do like, what is it? If you do like 2 over 5 minus 1, and then you get negative 3 over 5, okay? So plus 3x to the power of 2. Now, there is another law of exponents that says that a to the negative m is the same as 1 over a to the m, okay? So now, I prefer to write this with a positive exponent. So basically, we have like dx, okay, of the fifth root of x squared plus x to the power of 3. The answer is 2 over 5 x to the power of negative 3 over 5 plus 3x squared. You can write it that way, or you can also write as following this law of exponent mentioned here. This will be 5 at the denominator here, the fifth root of x to the power of 3, okay, all under 2 plus 3x squared. It's the same thing, okay? So I just move this part here. You know, with the negative sign, it moves down, okay? I have like x to the power of 3 over 5. But now using this law again, this operation, I can write it back in the roots with using the root sign. So this is the final answer. You don't have to write the two answers. You can write one and it is correct. Unless they say write it with a positive exponent and use the radical sign, then you can write the way I did again. So this is the answer. Okay, and then the following question is 7.2.2. What does it say? Let's see. 7.2.2 says that f prime of x, if f of x equal to 4x squared minus 9 over 4x plus 6, and also x is not equal to negative 3 over 2. It's different than negative 3 over 2. Now let's move the board like this, and then I want to write my question here, 7.2.2. We have like looking for f prime of x, okay? And then f of x itself is given by f of x itself is given by 4x squared minus 9 over 4x plus 6, okay? And then we have another condition here. The restriction is that x cannot be negative 3 over 2. Now, who can solve this? How can we do that? Again, it's going to be easier for us to simplify the function before solving it, okay? I think it's better that way. F of x, we can change f of x. When I see 4x squared minus 9, you'll notice that 4 here is a square number. X is also squared because it's raised to the power of 2. 9 is also a square number. So we have like a difference between two squares. This is a square and that is a square. Remember, there is a law that says that a squared minus b squared equal to a minus b times a plus b, or vice versa. So we can apply the same difference between the squares. 4x squared can be written as like 2x to the power of 2, okay? And then this can be written as 2x to the power of 2. And then 9 is also like 3 to the power of 2. Okay, so at the denominator here, 4x plus 6, we can also simplify. You notice that there's a highest common factor between 4x and 6. So we can take 2 out as a common factor. Okay, so it's going to be something like that. And then in the brackets here, it will be like 2x plus 3 there. And now we can continue solving this by saying that f of x will be equal to applying the difference between the squares properties. So this will be like 2x minus 3, okay, in the bracket, and then 2x plus 3. So 2x is like your a, and then 3 is like your b here. So like a squared, b minus b squared. So it's going to be like a minus b, so 2x minus 3, and then a plus b, 2x plus 3, all over 2x plus 3. Now we can solve this by simplification. We can simplify that, and then we have like this means that f of x equal to 2x minus 3 over 2. Now we can simplify this further because there's another law or another property, I prefer to put it like that, that says that if you have like a plus b plus c plus dot 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 plus z, okay, let me just not write a lot. I can just write a plus b. Stop there. A plus b over c. Oops. A plus b over c. This is the same as a over c plus b over c. Okay. So now we had like it was over 2. Okay. So we can write this as okay. I'm afraid to do it here. F of x can be written as like, okay, this is going to be, okay, I'll write it 2x over 2 minus 3 over 2, okay? And then we can simplify 2 and 2 there, and then the answer here will be like x minus 3 over 2. So far we didn't differentiate anything. We just transformed the equation by making simpler and simpler, simple for us to differentiate it. Now we can differentiate this by using the law of differentiation. That's we stated here. Now I want to add one more rule. Another rule says that the derivative of all constants, okay, of any constant is just 0. So over here, note that the coefficient is just 1 and then the exponent is 1. Okay, so a is 1, n is also 1. And then this can be written as like 1 times x to the power of 1 minus 1 minus 0 there. And then this makes what? All this is just to the power of 0. So meaning x to the power of 0 is just 1. So we have like 1 times 1 times 1, which is 1, minus 0. So the answer is 1. So f prime, that's f prime of x is just equal to 1. Good. Okay. So now let's see the following. If the general, okay, that was the last question. Thank you.